Hello students, today we are doing lesson 5.3, prime and composite numbers. First we're going to make a little chart here. Okay, we're going to go down 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, go across. Okay, and then right here we're going to put number, okay, and then we're going to have factors. And then at the end, we're going to, you could just put P or C. So that stands for prime or composite. Okay, so here's our little chart. We're going to do a quick learning what prime and composite are from starting with our numbers 1, 2, 3, 4, 5, 6. Okay, so you learned what factors were in lesson 5.1, and you wrote out factors for different numbers. So if I were, let's start in the middle of the group. Let's start with 3. What are the factors of 3? Well, 1 times 3 is the only way you can make 3 with multiplication. So 1 and 3 are our factors. Okay, now I started with 3 because I didn't want to start with 1 because 1 is a little bit special, right? There's only one factor to 1, and that's 1, because 1 times 1 equals 1, and that's the only multiplication fact that equals 1. Okay, and we're talking about whole numbers, right? We're not talking about multiplying fractions or decimals or things like that. We're talking about just whole numbers. So 1 times 1 is 1. So the factors of 1 is just 1. Okay, for prime and composite numbers, prime numbers have exactly 2 factors. And composite numbers, composite, like a composite rock and things like that, that means it has more than, it means it's made up of a lot of things, right? So more than 2 factors. So that means 3 factors, 4 factors, but it has to be more than 2. Okay, well, let's start with the number 1. If 1 has only 1 factor, does it fit here? Exactly 2 factors, or fit here? More than 2 factors. Hold on, I gotta erase both of those little circles. No, it doesn't work with neither one of those. So 1 is neither. It is not prime or composite. Now the rest of the numbers 2 through 1,000,000 are either prime or composite, but not 1. 1 is neither one of those because it does not meet the definition of either one of those. Okay, what are the factors of 2? Well, for 2, we have 1 and 2. Okay, there's no other numbers. So 1 and 2 are the factors. So look at the definitions. Is it going to be prime, exactly 2 factors, or does it have more than 2 factors? Well, it has 2 factors, exactly, so it's prime. 3 has exactly 2 factors, so it's prime. Okay, what about 4? What are the factors of 4? See if you can list them. Okay, you should have said 1, 2, and 4. Because 1 times 4 is 4, and 2 times 2 is 4. So those are the factors. So since this one has 3 factors, this is composite. Remember, composite has more than 2, and 3 is more than 2. Okay, 5 would be 1 and 5. So that one's prime. It only has 2 factors. And 6 is 1, 2, 3, and 6, right? Because 1 times 6 makes 6, and 2 times 3 makes 6. Oops. So that one has 4 factors. So 4 factors means it's composite because it has more than 2 factors. Okay, let's go on with some other numbers. I want to talk about some other prime numbers. We're going to go through all the numbers 1 through 20 and list the prime numbers. Well, we just learned this one, and this one. We learned the first 3, and that was 2, 3, and 5. Remember, 1 is not prime. Okay, I'm going to say that many times, and hopefully nobody gets it wrong on worksheets and even on the test. Okay, so if 2, 3, and 5 are prime, let's keep going and talk about the rest of the numbers. 6 we know is composite because it was on our chart. What about 7? 7 is prime. 8, no, because 8 has more than 2 factors. 8 would have 1, 2, 4, and 8. So 8 is not prime. What about 9? A lot of kids see that these are starting to be odd numbers, so they think 9 is the next odd number and it should be prime, but it's not, because 3 times 3 is 9 and 1 times 9 is 9. So 9 is not the next prime number. Okay, not 10. We're not going to have any more even numbers, so that's because the 2, any even numbers can be multiplied by 2 also. Okay, so not 9, not 10, but 11 is our next one. Not 12 because it's even, but 13 is prime. 14 is not. 15, okay, that's on my next odd one. Is it prime? No, it is not, because 15 can be 1 and 15, and it can also be 3 times 5. Okay, 16, no. 17, yes. 17 is my next one. 18, no. 19, yes. And 20, no. So those are my first prime numbers up to 20. You can keep going and going and going and going with prime numbers. You're going to see that they get a lot farther apart as you keep going, because they can be divided by each other. Okay. Okay, and then my examples are, let's see. It says state whether, well, we already answered that one. Oh, here's one. So we'll just call this example 1 because we kind of did example 1 already. And it says, is 57 prime? Okay, so that's kind of a hard one because it looks like it's prime. It's odd, and all I can think of is 1 and 57. But I know a way from my last lesson in figuring out if this can be divided by other numbers. If it can be divided by a number, that means that's one of its factors, right? It's like 16. If 16 is 1 and 16, right? 1 times 16. And if it can be divided by something else, like 4, that means 4 times 4 is its other factor. So I'm going to use my divisibility rules to figure out if this is prime. So I'm going to go through all my numbers, 2, 3, 4, 5, 6, 9, and 10. Those were all the ones we learned divisibility rules for. So can it be divided by 2? No, because it's not even. Can it be divided by 3? My divisibility rule says 5 plus 7. Remember, add the digits. So 5 plus 7 makes 12. Is that divisible by 3? Yes. So 57 can be divided by 3. And I'm actually going to divide it by 3 so I can show you. Okay, so that's going to be, let's see, I'm subtracting 19. So, and no remainder. So 57 has factors of 1 and 57. But it also has 3 and 19 as its factors. So it has 4 factors to it. These are its factors. So the answer to my question, is 57 prime, is no. Okay. So remember, another reason why we learn divisibility rules is to tell if something is prime or not. And we're going to use these prime numbers in a lesson in about 2 more. What are we on? 5.3. We're going to do it in 5.5. You're going to need to know your prime numbers, or if something's a prime number, and you can use divisibility rules to figure that out. So that's it for today. You will be asked questions like, are these numbers prime or composite, in your homework, and so you will just need to write prime, composite, or neither. The only one who is neither is 1. So make sure that you don't write prime or composite on 1. And that's it for today.